So what I'm drawing here is the relationship of the cutter to where it lines up with the center of the rotary table. And we're going to borrow a term from machine tools, or cutting tools rather, called rake. But we're going to assume, and correctly so because I've checked, that the paw, or rather the pedal bearing surface, is coming in at a neutral position. So that means lined up with my ruler towards the center of this rotating shaft. The angle we're talking about is how it meets the line of the tooth that's already cut. So you see here, if the paw comes in at this angle, it only makes contact with the leading edge of the tooth that's on the positive rake, we're going to call it. So positive rake, we're going to imagine the center comes to there. So if I had a bunch, all those lines would come to that position. So I'm going to draw a pair for each one here real quick. This is called a dovetail cutter, and this particular one has a 60-degree angle on it. Some ratchets might have a 45, but I like to use the 60 because it makes a smaller tooth, allowing a finer adjustment on the ratchet. That cutter is going to come in and make that line. So if we bring the cutter farther down and farther over, it's going to create this neutral rake that we're looking for. That's what we want. So wherever that points, we want it to be as close to this center point as we can get it. And the reason being, the paw, when it comes in, it's going to meet up nicely with that neutral rake. If we bring it down at this same angle, this red line here only makes one contact point, and it's right there on the bottom. And one other problem with this is there's potential, if this doesn't match up, it's not going to go in as far as it possibly can unless the tooth is bigger than the paw, which is possible to do, so you get like a knife edge. But the problem with that is you have less stability and less strength. This is all set using the mill height. Imagine this is the giant rotary table. It can go up and down, and the cutter can stay where it's going to be. This is the paw that comes in to meet. The reason that pedals slip is because the pressure is going back that way. And if this has any give or any rocking motion, it's going to want to break back like that as the pressure pulls it, and it's just going to slip past that edge right there. With neutral rake, or no rake at all, it's going to tend to stay locked in. With negative rake, as the pedal pushes up, if this has any wobble, it's actually going to engage a little bit better. It's going to make it suck down into the tooth a little bit more. However, having it this far apart, it's going to cause problems on either negative or positive. So given a choice, neutral is going to be the best, negative is going to be second best, and positive is going to be something we don't want. The ones that we made, we ended up getting a point right about there. So for me, this gets a little bit of the negative rake and more of the neutral rake than anything else. And with the potential slop intolerances in the pedal, it's usually going to fall towards neutral unless you have it on positive. So an older pedal that's worn out that has a bit of a positive rake is going to slip. So a machinist might look at this and go, you have these backwards. Well, we're talking about the ratchet in relationship to the paw. If we were talking about the paw angle, it's going to be actually backwards. So if you have a neutral cutter, pretend this is a cutter and the cutter is traveling in the direction of our pressure, that's neutral. That's actually negative because it's going to cause a lot more pressure on the cutter because it's going to engage more. And this is going to be positive because it's actually digging into the work as it goes. And again, that's where the idea comes from, that this particular angle, whatever you want to call it, works the best to engage the ratchet.